Alright, you are welcome again. Today we are still considering numerical analysis, and under numerical analysis we are considering Newton's method or Newton-Raphson method. Let's take a look at today's problem. We have derived the Newton's method for finding the cubed root of a positive number n. Derive the Newton's method for finding the cubed root of a positive number n. Okay, like n raised to power 1 all over q. Q can be any number, and then where n is positive and q is also positive number. All right, yes. And then the second part say, hence compute 17 raised to power 1 all over 3 correct to 4 decimal places, assuming the initial approximation as x naught equal to 2. Okay, good. Now let's go. Solution. The first thing we do is we make this assumption. We say let x equal to n raised to power 1 all over q. From this place we try to make n the subject. Okay, so we remove this power exponential. This is 1 all over q. So for us to remove it, we are going to multiply both sides by the inverse of the exponent. Okay, so we are going to multiply both sides by power of q. Multiply both sides by the power of what? Q. So when you do so, we are going to have x raised to the power of q is equal to n. Let's take n to the other side. We are going to have x raised to the power of q minus n is equal to 0. So this is our f of x. So we simply say that f of x is equal to x raised to the power of q minus n. Okay, x raised to the power of q minus n. So, but you know that Newton-Raphson requires a first derivative. So we find the differentiation. Okay, the first derivative gives us f prime of x is equal to q x raised to the power of q minus 1. All right, yes. Now I'm very sure you still remember Newton-Raphson formula, right? That says x n plus 1 is equal to xn minus f of xn all over f prime of xn. Is that clear? Yes. So here we have our f of xn, and then we have our f prime of xn. Okay, let's do simple substitution. Now, simple substitution, we are going to have xn plus 1 is equal to xn minus x raised to the power of q n minus n all over q x raised to the power of q minus 1 subscript n. Okay, simply we simplify or we combine this together. So combining this together, we have xn plus 1 is equal to q x raised to the power of q minus 1 n times xn minus x raised to the power of q subscript n minus n in bracket all over q x raised to the power of q minus 1. All right, yes. Now let's simplify the numerator. Simplifying the numerator, here we have xn plus 1 is equal to, now here we have x raised to the power of q minus 1 multiplied by x. All right, here the base is the same. The base is what? Is the same, x. So but they have different power, so we add their power. So when you add their power, it's going to subtract 1. It's going to remove the minus 1. Okay, when you say minus 1 plus 1, it will go. So therefore we are going to have q x raised to the power of q, then we have n. Now in this bracket, we open the bracket, we are going to have minus sq, then we have plus n. Is that clear? Yes, all over q x raised to the power of q minus 1. So here now we have used Newton-Raphson, and then the equation that we came out with is xn plus 1 is equal to q multiplied by x raised to the power of q minus x raised to the power of q plus n. all over q x raised to the power of q minus 1. Okay, so this is the Newton's method for finding the cubed root of a positive number. Okay, now the B part of it says, hence compute 17 raised to the power of 1 over 3. So in this place, n is equal to 17, q is equal to 3, and then our starter, which is x naught, is equal to 2. Okay, x naught equal to 2. So the formula we just derived now is this. So for n equal to 0, so when you say that n is equal to 0, what are you going to have? We are going to have x1 is equal to q x naught raised to the power of q minus x naught raised to the power of q plus n all over q x naught raised to the power of q minus 1. Okay, good. In this place now, we know our q, we know our n, and we know our x naught. Substituting, simply we have x1 is equal to 3 times 2 cube minus 2 cube plus 17 all over 3 times 2 raised to the power of 3 minus 1, then 3 minus 1, 2. Okay, so here we have 2 raised to the power of 2. So simplifying again, in this place where we have 2 raised to the power of 3 is 8. So here we have 3 times 8 minus 8 plus 17 all over 3 times 4. So here we have 3 times 8 gives us 28 minus 8 plus 17 all over 3 times 4, 12. So when you say 24 minus 8 plus 17, it's going to give us 33 all over 12. So x1 is equal to 33 all over 12. Then when you divide and then collect to 4 decimal places, we are going to have 2.7500. Hello? Yes. So computing and then writing in 4 decimal places, we have 2.7500. So here we treated how to use Newton-Raphson to derive the cubed root of a positive number, and then the second part we experiment our formula, okay, using 17 raised to the power of 1 over 3, and then the initial approximation to be 2. So the answer we got is 2.7500. Thank you very much for watching. Please let's continue taking more mathematical problems gradually. Please, if you are new to our YouTube channel, do well to subscribe, turn on the notification, like and share our videos, and stay blessed.